This video is going to be on section 8.2 on one sample intervals for the proportions. So we're going to run through the entire step-by-step process here on calculating a confidence interval for one population proportions. So in this case, we are wanting to estimate the population proportion P. For instance, you may be curious as to what proportion of students at your school smoke, or you might wonder what the proportion of accidents caused by teenage drivers who don't have a driver's education class is. Things like this. So step one, we state the random variable and the parameter in words. Here, x will be the number of successes, and p will be the proportion of successes. In step two, we state and check the assumptions for a confidence interval. We make sure that a simple random sample of size n is taken, that the condition for the binomial distribution is satisfied. And to determine the sampling distribution of p hat, we need to show that n times p hat is greater than or equal to 5, and n times q hat is greater than or equal to 5, where q hat is just 1 minus p hat. If this is true, then the sampling distribution of p hat is well approximated by a normal curve. In reality, this isn't really true since the correct assumption lies with p, or the correct assumption deals with p. But in a confidence interval, we don't know p, so we have to use p hat. We really just have to show that x is greater than or equal to 5 and n minus x is greater than or equal to 5. Step 3 is find the sample statistic and the confidence interval. This is kind of a lot of information. And we're going to have to say what this is and then talk about some of this in a second. But the sample, the confidence interval is p hat minus e is less than p is less than p hat plus e. Where here, p is the population proportion. P hat is the sample proportion. N is the number of sample values. E is the margin of error. And Z sub C is the critical value, where C is 1 minus A. Or 1 minus alpha, sorry. Q hat is 1 minus P hat, and E, the margin of error, is Z sub C, that's the critical value. We're going to talk about how to find this critical value, times the square root of P hat times Q hat all over N. And one thing that we didn't have up here was that P hat is X over N. It's just the number of successes divided by the number of trials. In step 4, we have our statistical interpretation. And in general, this looks like there is a C% chance that P hat minus E is less than P hat plus E contains the true proportion. And the real world interpretation is just where we state what interval contains the true proportion. The critical value is a value from the normal distribution. Since a confidence interval is found by adding and subtracting a margin of error amount from the sample proportion, and the interval has a probability of containing the true proportion, then you can think of this as the statement I accidentally changed something here. There we go. You can think of this as the statement probability of p hat minus e is less than p hat plus e is equal to c, where c was our percent chance that this captures the true population proportion. You can use INV norm on the calculator to find the critical value. We would use INV norm 1 minus alpha over 2. Since there's since the confidence level of alpha leaves an area of alpha over 2 at each end of the normal curve. There's an image on the next slide to demonstrate this. And some of these values get familiar. For instance, when we see a 95% confidence interval, we know that our critical value, z sub c, should be 1.96. And you see, whenever we have an area of 1 minus alpha here in the middle, this leaves tails of alpha minus 2 and alpha minus 2 on either end. Or alpha over 2. Sorry, I misspoke. The standard error, E, or this is part of E, rather. One important part of the calculation, this is the part that's being multiplied times the critical value, is the square root of p hat times q hat all over n. We refer to this as the standard error. You may think of this as the standard deviation of the sampling distribution, although that's not strictly true. The confidence interval is always a point estimate plus or minus a margin of error, and the margin of error is always a critical value times a standard error. We have an example here. A concern was raised in Australia that the percentage of deaths of Aboriginal prisoners was higher than the percent of deaths of non-Aboriginal prisoners, which is 0.27%. A sample of 6 years of data was collected, and it was found that out of 14,495 Aboriginal prisoners, 51 died. Find a 95% confidence interval for the proportion of Aboriginal prisoners who died. So we want to go through all of the steps where we state our random variable and our parameter in words. For instance, X is the number of Aboriginal prisoners who died. P is the, lowercase p, is the proportion of Aboriginal prisoners who died. Let's go ahead and move on to the third step. The second step, we don't typically have to do, well, you should do if you're actually conducting a study. If I'm assigning you a problem, then you probably don't have to go through those steps, right? Let's find the sample proportion, p hat. So p hat, the sample proportion, is x over n, which is 51 divided by 14,495, which is about 0.003518. Z sub c, our critical value, We actually discussed earlier that for a 95% confidence level, we use the critical value of 1.96. Common critical values can actually also be found in an appendix at the end of the textbook. I think it's Appendix A1. So for our margin of error term, E, we get that E is the critical value times the square root of p hat times q hat times n. This ends up being 1.96 times the square root of 0.003518. This is the p hat that we calculated, times 1 minus p hat, because q hat was 1 minus p hat, all divided by the sample size, which is 14,495, and we get 0.000964. This means that our confidence interval, p hat minus e, is less than p hat plus e. I can put this in right here. Is 0.003518 minus 0.000964 is less than p, which is less than 0.003518 plus 0.000964. And we get that the confidence interval is 0.002554 is less than p is less than 0.004482. And our statistical interpretation here is that there is a 95% chance that this interval contains the proportion of Aboriginal prisoners who died. We're going to look at one more example using a calculator. We can actually use a calculator to solve some of this stuff for us, which makes it nice and easy. It's nice to be able to calculate this by hand like this, and it's not terribly difficult, but there are calculator functions that will do this for us. Our example here is a researcher is studying the effects of income levels on breastfeeding of infants, and hypothesizes that countries where the income level is lower have a higher rate of infant breastfeeding than higher income countries. It's known that in Germany, considered a high-income country by the World Bank, 22% of all babies are breastfed. It's a typo. In Tajikistan, considered a low-income country by the World Bank, researchers found that in a random sample of 500 new mothers, that 125 were breastfeeding their infants. Find a 90% confidence interval of the proportion of mothers in low-income countries who breastfeed their infants. So what we want to do here is we should still state our random variable and parameter in words. X is going to be the number of women who breastfeed in a low-income country. And P is going to be the proportion. Now, to find the sample statistic and confidence interval, we can do this all at the same time. Now we're going to use a calculator function called 1propzint. We access this on our TI-83 or TI-84. If you don't have one of those, I believe you can just Google 1propzint and a good calculator will pop up. Yes, I think that this website that you see here is a good one. There are multiple good online calculators that will do the same thing for you. In a TI-83, or a TI-84, you go to Stat. I had to reboot my calculator there. It wasn't working for some reason. You go to Stat, Tests, and then we scroll down to where we see one prop Z int, not test. We want to make sure it's one prop Z int. And this is the option that has an A next to it, one prop Z int. We hit enter. For X, we type in the number of successes. So in this case, this is 125. For N, we type in the sample size, which is 500. And for C level, you just type in the confidence level, which is 0.90, because we are looking at a 90% confidence interval. And then calculate. And the calculator readout gives you your confidence interval. So our confidence interval is just 0.21815. It's less than P is less than 0.28185. The statistical interpretation here is that there is a 90% chance that this interval contains the proportion of women in low-income countries who breastfeed their infants. And this is it for section 8.2.